So with that in mind, how do we go from bytes, which is base 2, into kind of a base 10 system, into the values that we humans use to communicate? Well, in the same way that we had in a base 10 system, the rightmost digit is the 0th digit. So here it's the 0th bit, which can be either 0 or 1. And that's because it corresponds to 2, because it's a base 2 system, to the power of 0. So this is still the ones place, just the same as the system that we know. But now the next bit here corresponds to 2 to the power of 1. So 2. And if we continue the pattern, 2 to the power of 2, which is 4, 2 to the power of 3, which is 8, and so on and so forth. And so because we have 8 digits here, but we started from the 0th bit, then the first digit in the set of 8, because there's 8 bits in a byte, corresponds to 2 to the power of 7. So it's 128. And now, just as we did for base 10 numbers, the way we get the value of this, this byte is by adding up all of the corresponding values for bits that are equal to 1. Because really we're doing the same thing as we did before. So before we had in base 10, if a 4 was in the 10,000ths place, then that 4 meant actually 4 times, if the 4 was in the thousandths place, it would mean that 4 times 1,000, 4,000. So here, if you have a 1 in the 64ths place, that's 1 times 64. But it's kind of nice because in a binary system, you can only have zeros or ones. So we get, we either add the number or we don't. We don't ever have to multiply by more than 1. So adding these together, we get 64 plus 8 plus 4 plus 1, which gives us 77. Now, why don't you try this yourself? Pause the video for about a minute and see if you can decode what this byte, what the value of this byte is. I'll wait for a couple seconds. Okay, and we're back. So let's see if you got the right answer. So again, we start from the right because the right is the 0th bit always. And then each bit corresponds to a power of 2, starting from 0 from the right. So 2 to the 0, 2 to the 1, 2 to the 2, 2 to the 3, and so on and so forth. So here we have a 1 in the second place, because again, we're starting from 0. A 1 in the 4th power, and a 1 in the 6th and in the 7th. And so adding all of those together, 128 plus 64 plus 16 plus 4 gives us 212. Okay, one more practice problem. What is the maximum value that a byte can hold? Take a minute, see if you can figure this out. Pause the video, and I'll continue in 5 seconds. 5, 4, 3, 2, 1. Okay, we're back together. Let's see if you got this. Well, given that anytime you have a 1, you add the value that it represents, and anytime you have a 0, you don't include it, then the maximum value must be when the entire byte is made up of 1s. So all 8 bits in the byte have a value of 1. So if we do that and we add up all of their corresponding values, we get 255, which is the maximum value that a byte can hold. Okay, our last topic for this lecture will be running code. So now that we know a little bit about binary instructions, and so binary is made up of 1s and 0s. Those 1s and 0s are called bits. 8 bits make up a byte. Byte can be translated into base 10 numbers. I want to take just a minute to summarize and put it all together and connect it back to the code that you're going to be writing. So you're going to write some code that looks something like this. And this is num people equals 5. You don't need to worry yet about what that means. We're going to learn that in future lectures. But when you write some code and you actually want to run that code, we need to translate it into a language that the computer can understand. And so we start with num people equals 5, and by pressing the run button, you give it to a compiler that translates that code into actual bits or bytes. And then this byte code, which is binary, is given to a computer, to the computer that you're running the code on. And then that computer can actually execute that code, run that code, and calculate something. So do something, provide some output, could be show an image, could make a sound, whatever you tell it to do. Okay, now that we have all of that put together, let's talk about next steps. So this week, homework 1 is out now in Mimir. It'll be due by 11:59 on August 30th, but refer to Mimir or the class website for the fully accurate date in case it changes. Wednesday's lecture this week will also have no pre-class video assignment, but starting next week, there will be lecture videos released before every single class, and you have to watch them before coming to class. Nothing this week, but starting next week. I'll remind you again in the next lecture. And finally, just remember Lab 1 on Thursday. Professor Chaudhry will be running the labs, and you're going to get to run some of your own code for the first time, which will be very exciting. Before I fully wrap up, I just want to take a minute and give some credit and share some credit where credit is due. Some of the formatting for these slides and theory of education are largely from one of my past professors, Josh Hugg at UC Berkeley. And the course topics that you'll see in the structure, though it's written by me, takes a lot of inspiration from Berkeley's CS10 and CS61A, taught by John De Niro. And then slides, of course, thank you to Daniel Carbajal and Erdi Seidel, who are past CSCI100 instructors. But exams and quizzes absolutely will not be reused. Those will be certainly all original. Thank you for coming to the first lecture, and I will see you for Wednesday's lecture. Bye.